This exercise provides an opportunity for students to plot the change in elevation over time of two different individuals on the same set of axes. In this problem, the students are being asked to graph a man's elevation over time as he ascends and then descends the same flight of stairs. And they're also asked to graph the elevation of a girl who ascends the flight of stairs later in the video. As students are graphing, encourage them to label their axes and determine an appropriate scale to help them create an accurate graph. You can see that along the horizontal axis, we've chosen a scale of 2 seconds for incremental marking. And this is because the video is approximately 35 seconds long, and there are 20 different incremental markings along the horizontal axis. We've also chosen a scale of 1 foot in elevation for incremental marking because there are 13 markings, and the maximum height is just short of 11 feet. By watching the video, the students may struggle with determining the maximum height of the man, but you can use this information to help them. You can tell the students that there are 16 stairs on the flight of stairs and that each stair rises approximately 8 inches. So to find the maximum height, students can multiply 16 stairs by 8 inches per stair for a maximum height of 128 inches, which is 10 feet 8 inches or 10 2/3 feet. It's important that as the students are watching the video, you encourage them to determine the times of the man's start, his completion of his ascent, the rest period, the beginning of his descent, and the end of his descent so that they can graph accurately. It appears that the man starts to ascend at 0 seconds and reaches the top of the stairs between 10 and 11 seconds. Since his ascent seems to be at a constant rate, we represented this using a line segment. Then between 10 and 11 seconds and 18 seconds, he seems to rest, so there's no change in elevation during this increment. Between 18 and 28 seconds, he descends the stairs, again at approximately constant rate, so we used a line segment to represent this portion of the graph as well. At about 20 seconds, or shortly thereafter, the girl begins to ascend the stairs. So we begin her path at slightly after 20 seconds. Again, she ascends at a fairly constant rate, so we're going to represent hers using a dashed line segment. And you can see that she reaches the top of the stairs somewhere around 32 seconds. So this graph represents the change in elevation of both individuals. And it also indicates when the two cross each other's paths, where these graphs intersect right here. If we look at the scale, we can see that this occurs at about 24 seconds and at an elevation of 4 feet. And I would encourage you to have the students go back to the video and confirm that the intersection point on their graphs is roughly at the same time and maybe at the same elevation as what they see on the graphs here.